Okay, recording's good. All right, welcome. Today I'll be going over Tomghost's room on TryHackme's platform. Tomghost is showing off a new exploit within Tomcat that allowed the ability to read files on the system. These were key system files that could have username and passwords in them, and so we'll look at that. We'll look at the exploit and then look at how to leverage leverage our privileges to an administrative level and gain more access to the system. So let's look at the box. So this is the box on TryHackme's platform. This is a free room, so you can follow along. This is a challenge box, so there's no guidance on this one. All it provides you is just the two flags. It just wants the two flags for the answers. So with any box, what we'll start doing is scanning. So we'll start by putting the IP address of our target into our targets file. And then we'll start off with an nmap scan. So we'll do it nmap il. We'll do a -pn -t5 and -put all formats, and we'll call this one Tomghost. And it comes back quickly. We see some open ports. We see SSH, domain, AGP, and port 8080. Even though Nmap reports that port 8080 is just a HTTP proxy, we want to look at that further because sometimes web servers run on port 8080. So we'll go ahead and get a detailed scan going. And since we had saw other ports, what we'll do is we'll try to invoke any scripts that Nmap has on there. So we'll do an AGP star, and then we'll also do HTTP star. And this basically is telling Nmap if you have any scripts that start with that, run those scripts. We're also going to specify the script timeout and do that a timeout of 2 minutes. All right, so that's going to be running. While that runs, let's look at the web page and see what we have. So looking at the web page, we see default Tomcat page, and with Tomcat, there's some major things that you want to check out and look at. Um, the manager app and the host manager. If you have access to these, what you can do is deploy WAR files. The WAR files are like packaged up web applications, and we would have the ability to run remote code on that server. But as we can see by clicking on each one of these, we're just access denied. On a normal instance where they allow username and password, a prompt will come up and you put that in. A good thing to note with older versions of Tomcat, if you clicked cancel on that prompt, you would be put to this page where you see the username and password. And a majority of the time, administrators never changed that or never updated it. So that was a way to get those OR files onto the page or onto the server. So we see that that's kind of locked down, and that's part of the newer versions of Tomcat that this is default locked down. So the other thing that we could go ahead and do is run GoBuster and see if we can discover any additional pages that maybe we're missing. Oops. All right, and then we're going to specify the word list. .3 medium here. And then we want to save that output -O. Okay, so now we have our recon going. We see that docs came back. That's a standard folder location for Tomcat. We still don't have anything out of Nmap. So the next thing that we could go ahead and start doing is looking at if there's any known exploits for Tomcat or the AGP port. So we'll start with the AGP port because it was higher up on the list. So we'll do search exploit AGP, and we can see that search exploit comes back with a very what we're looking for. There's Apache Tomcat AGP. They call it GhostCat file read and inclusion, and this is under web apps. And so this kind of indicates that maybe this is the exploit that we're looking for. But, we could also do search exploit, look for Tomcat, and there's going to be a lot more Tomcat things in there. Again, noting the version number 9.030, we could look at the results here and see if any of these would work. We see some 9.0.1 and then earlier versions of Tomcat. So let's just stick with the AGP one. So with search exploit, each exploit has a number, and in this case, the number for this one is 48143. And what we need to do is we're going to copy this exploit to our current directory by mirroring it. So we'll do search exploit and then -m and that number. And now this is copied over to our current working directory. And we can see that there. We'll go back and look real quickly at our scans just to see where they're at. Our Nmap scan looks like it's finished up. We see that it was able to do a little bit more detail. We see for the AGP port, it does pull out some information. On port 8080, we're seeing that it's just a Tomcat page, that it apparently identified an IDS, a WAF. Nothing more from that. And then for GoBuster, it's still going. We see docs, examples, and manager. Again, those are standard locations. All right, so let's look at our exploit and see what this exploit entails. I'll be running Visual Studio Code. And then we'll need to specify the user directory. All right, Visual Studio Code's loading up. Let's make this a little bit bigger. So reviewing this file, we see that it's Python, that we're building some structures, the references to the AGP connector there. Again, AGP is a protocol, so you have to kind of build that data when you're sending it to the web service. It's a little bit similar to HTTP, but different. in the way that it has structures and things like that. And so we're packing data, we're unpacking data. This is usually part of like when we're serializing things. We see the AGP body request here. We can see that the max length is 81886. Pumping some of the stream data into the class. We're looking for certain bytes. And then we're going to send and receive that data to the server. Here's some of the headers of this looks like. Options, get, head, post, put, delete, trace. Some of the attributes that are needed to submit this data, like the SSL cert, cipher, session, key. And here we're building a structure, putting all that data into basically this class. That's what self is for. And then we're going to pack the headers, set up the headers so that when you send that request out, it has everything correct. There's a serialization. And then it needs to parse that data, send or receive it. There's some cookies. It's saving any cookies that come back to make further request. Then we can see that they made a class for AGP response, so we're getting that response back. We see the cookies. There's the if it came back with an authenticate header, we're looking for that, grabbing that information out. And so this is all stuff that managing basically your session, and then we're preparing the forward request. We can see here this is similar to what you would see on a web page. Request, we accept text and HTML. We're keeping the connection alive. We're using a user agent, any encoding, things like that. And then there's the Tomcat class, basically performing the request, connecting to the stream. And then at the bottom we have our options and stuff like that. So looks all pretty good. So let's see what we can do with this. So we're going to run that Python script, and the first thing that comes back is that the user environment Python/r, no such file or directory. So whenever you're running scripts, the first thing that you do on the top of your script is you put basically, like if this is using some type of interpreter, like bin bash or Python. So in our case, it's not able to figure out what we're calling here, and the reason for that is if we look up where Python's at, we don't have it in our environment variable. We have it in user bin Python. So we can edit the file and just fix that. All right, so we'll save that, and now if we try to run this again, now we get a bad interpreter. So usually when you get a bad interpreter, what this means, especially when you see this $m, is that this file was created on a Windows host and then copied over to a Linux host. And Windows ends up putting these meta characters inside the file almost every line without you seeing it. And so we can see that in our editor, we don't see any of those characters, but they're there. So the way you fix this is do a DOS to Unix and then that file. And that's going to convert it to a Unix format. And so now if we run it, we actually get to run the file, and it presents the error message that, a normal error message. So we can look at the details of this help file. And we need to provide a target. Target needs to be last, and then we can specify a port or a file, any other additional files. We'll leave those as default. So all we need to do then is just specify the IP address. So let's grab that. So we run the request and it's really quick coming back. We can see that it was querying that AGP port, and then querying a resource for ASDF, and then it was able to grab that web.xml file. And that's what the result is here, is this web XML file. We see this is a standard Apache file that's provided. Um, it has some XML content in here to kind of set up maybe some configurations and things, a version, um, display name, welcome to Tomcat, and then description, welcome to GhostCat. And then this looks like, basically credentials. So we're going to copy those. We'll echo those out and put that into a file in our directory. And now we have them in there. So the only other port that we had that we could potentially use credentials on was SSH. So we'll go ahead and try to SSH into the server. All right, we're on the server. We'll make this window bigger. And again, our only objectives is to obtain the user flag and the administrator flag, the root flag. There's no other objectives for this box. So let's look at our current directory. See what we have in here. So looking at our current directory, we see that we have a bash history file, then that's not pointed to dev null. We have some other additional files. We have a credential PGP and a tryhackme.asc. So first thing I would look at is the bash history file. And we see that the user was CD'd into this directory. It looks like they pulled the ASC and the PGP file from somewhere and then just left it in this directory. So not much details there. So what we want to do then is let's grab those files off of the server and see what we can do with those. So we'll make a directory called files on our main system. We're going to SCP those. So it's SCP and then at the IP address. And then colon and what we want. So we're going to want this directory basically. And then we're going to copy that into files. So then you need to put the password. And so it said it's not a regular file. So we'll just do a -r that way. All right. And so now that's copied everything into our files directory on our local system. We see the directory and we see the files. Excellent. So looking at these files, we see that this is the ASC is a private PGP block. And based on the credential PGP, that's probably the PGP. So um, we need to basically know the password for this PGP thing. And so what PGP is that you add these keys to your keyring, and then you're able to kind of decrypt data. Um, and so to convert this to something that we can do with, we're going to do GPG to John. We're going to specify that file, and then we're going to basically make it a hash that we can crack. And so now we have a hash.txt. And if we cat that hash.txt, you see that there's the user, there's the type of data, and then there's the hash basically. And so now we can have John crack this. So we're going to use rocku. We're going to do that hash.txt, and then we're going to specify that we want our pot file to be saved here. There we go. So Tom tried all the possible passwords. Again, identified that it was a GPG hash that it was trying to crack. Ran through all those, and it found this password here. All right, so in order to read that file, we need to import that key to GPG. So we're going to do a GPG import. Then you specify that private key. I've already done this. So what it will ask you for is that password, and you put in that password, and it'll successfully import that key. With that key on your keyring, then you can decrypt the file now. And so now this is asking for that password, which is the same one that we had from before. Oops. And once you type that in, it's going to decrypt that data. And so you can see this is the data inside that file. So we're going to put that into another text file. Again, we're just trying to keep making sure that we have this data somewhere so that we can get access to it if we need be. We're currently already logged in as somebody, so we'll need to exit that session and then try this new person. And so for their password, it is very long. All right, so now we're logged in as Merlin, and same thing. We kind of want to look around, see what we have access to. We can see that same thing. They have their bash history, and it's there. It's not pointing to null. We do see the user flag, so that's good. That's the first user flag that we need to get, but we're still not, um, any administrative level basically. So let's first look at the bash history, see if we got anything out of that. And so apparently I can't cut out the bash history because it's owned by root. So that's not going to help us out. We do see an interesting file that says sudo as admin successful. Um, so we can see that that has no bytes in there, but that would give us an idea to try sudo-l and see what permissions that we have. Um, we do see the level of permissions that we have is that we can run user bin zip, and it runs as root with no password. So we can run zip without any password. So this is where we need to look at GTFO bins. So these are built-in binaries on the Linux system. There's also, a equivalent for Windows, LOL bins, living off the LAN. And we'll put in zip in here and see what different functionality that we can do. So we can get a shell, we can do sudo or limit sudid. We have sudo privileges, so this is one that we'll use right here. All right, so we'll just clear this out. I'm gonna paste this in here. And we get a pound prompt, which usually it indicate of root. So we're trying to type who am I? It says we're root. If we do bin bash, we'll get a prompt back. So now we see that we're root at Ubuntu. So now we're root on that system. And if we look at the file system for root, we're still in Merlin's directory. So let's do home root. Well, let's just do home, or let's just do root, cd root. All right, and we see that there is the root flag. So that was a way to kind of, again, wrap up everything. We had a Tomcat vulnerability in the AGP port, allowed us to read, sensitive files. That file had a username and credential on it. Once we got onto that user, we saw that they had sensitive files in there that basically was password protected, but with a weak password. Once we added that PGP um, key to our keyring, we were able to decrypt the file, get another user's password, and that user had the ability to basically run zip as root, and zip has a permission vulnerability in it that allowed us to get access to the root user. So that's going to be it for this box. Thanks again, and enjoy.